Here we are working with a piecewise function, f of x. The domain is all real numbers from -2 to 2. The codomain, or range, is all real numbers from 2 to 10. On the interval from -2 to -1, the function is given by g of x. On the interval from -1 to 2, the function is given by h of x. The conditions are 1g of x and h of x are not the same linear function. Second g of x passes through the point -2, 2. Third g of -1 must be an integer. 4. Most importantly, f of x must be a one-to-one correspondence. That means it is both one-to-one and on-to between the interval from -2 to 2 and the interval from 2 to 10. Whenever you solve a function problem, the best place to start is always the domain and the range. If we sketch this on the coordinate plane, the domain goes from -2 to 2. The range goes from 2 to 10. Now let's build one example of a one-to-one correspondence function. Since the domain is split at -1, we first define the function on the interval from -2 to -1, and then separately on the interval from -1 to 2. For instance, if g of x goes from the point -2, 2 to the point -1, k, where k is an integer between 3 and 9, then h of x must continue from that point to cover the rest of the range up to 10. Notice, g of -1 equal 10 is not possible because then there would be no values left for h of x. So g of -1 can be any integer from 3 through 9. That gives us 7 possible choices. Next, from each of those points, h of x can extend in two different ways. For example, if g of x passes through the points -2, 2 and -1, 5, then h of x could continue upward, passing through the points -1, 5 and 2, 10. Or it could slope downward, as a line passing through the points -1, 10 and 2, 5. Both cases satisfy the one-to-one correspondence condition. So for each of the 7 choices of g of -1, we have 2 possible functions, h of x. That gives us 7 times 2 equals 14 functions. Finally, one of those 14 cases corresponds to the situation where g of x and h of x lie on the exact same straight line. But the problem states they must be different linear functions. So we subtract one case. 14 minus 1 equals 13. Therefore, the number of possible functions is 13. Notice that this function problem is also connected to ideas from counting and probability. In fact, determining how many functions are possible here is very similar to a combinatorics problem in probability and statistics.